Welcome to solverfy.
In this problem, we are asked to find IB, or the current in the base of the transistor, and VC, or the voltage in the collector, given this figure, and given the values of beta equals 100, and the voltage in the base emitter is zero point 0.7 volts. Now, we first start with the equation of Ohm's law as IB is equal to voltage in the resistor over the resistance. Let's change this here. Now, the voltage across the base can be associated with the voltage in the 10 kilo ohm resistor, and that is equal to the voltage at node C minus the voltage in the base emitter node over 10 kilo ohms. So we have an unknown here, which is the voltage at node C. We could get this from the equation of voltage division, or that is VC is equal to VCC, or our voltage source, minus the voltage in the 5 kilo ohm resistor. So 12 volts minus the voltage in the 5 kilo ohm resistor will give you the voltage at the node C. But what is the voltage across the 5 kilo ohm resistor? Now, going back in the circuit, if this is IB and this is IC, we know that the current passing through the 5 kilo ohm resistor is just the sum of these two currents. So that is IB plus IC. So the equation now becomes VC, or the voltage at node C, is equal to 12 volts minus IB plus IC times 5 kilo ohms. But we'll have to put an assumption here to simplify the problem, and that assumption would be IC is much, much greater than IB, which normally happens in a transistor. If that's the case, we say that the voltage in node C is approximately equal to 12 volts minus just IC times 5 kilo ohms, because IB is so small that we could remove it from the addition term here. Now this is our third equation. Let's put in another, this is our second equation. Now let's put in a third equation, and that is the relationship between the current in the base and the current in the collector, which is given by IB is equal to IC over beta. Now, substituting the second and the third equations in our first equation, we'll get the current in the base as equal to 12 minus 5 kilo ohm IC minus VBE over 10 kilo ohms. Now, IB from the third equation is equal to IC over beta. Isolating the IC, we'll get a term on the right side here as times 10 kilo ohms plus 5 kilo ohms IC is equal to 12 minus VBE. Now, we could factor out IC from these two terms, giving us the product of IC times 10 kilo ohms over beta plus 5 kilo ohms is equal to 12 minus VB. We get IC is equal to 12 minus VBE divided by this whole term here, 10 kiloohms over beta plus 5 kiloohms. Substituting the known values, we could get an IC of 12 minus 0.7 divided by 10 kiloohms over 100 plus 5 kiloohms. So notice that the numerator is in voltage and the denominator is in resistance. So we are still through to the equation of Ohm's law, where the current is equal to voltage divided by resistance. So we get an IC of 2.22 milliamperes. Now that we have an equation for IC, or a value for IC, we could get IB by substituting it here as IB equals 2.22 milliamperes divided by 100 for beta. That gives us a current in the base of 0.0222 milliamperes. Now box that as our final answer. Now to get the voltage in the collector in the node C, we go back to our second equation, and that is VC, oops, VC is approximately equal to VCC minus IC times RC. And that is equal to 12 minus 2.22 milliamperes times the resistance 5 kiloohms, or 12 minus 11.1 volts, giving us an approximate voltage for the node C as 0.9 volts. Now box that as our final answer.